Hey guys, Mr. Marone here. Welcome back in. We are in section 11.3 where we're going to be looking at area for the last time, and we're going to be looking at it with what's called shaded regions. So as you see in the pictures here for my examples, there are portions of our figures that are shaded, and that's what we're going to work on finding the area of. And they're very simple. To find the area of a shaded region, you first have to find the area of the outside figure, or of the shaded figure. And then you're just going to subtract the area of the non-shaded figures. So for our first example here, I've got my outside figure is a square. And my non-shaded figure, my inside figure, is a circle. So what I'm going to do is find the area of my square, and then I'm going to subtract the area of my circle, and that's going to give me the shaded region. Picture this as like you're punching a hole in a piece of paper. You want to know what's left in the paper after you've punched the hole. So what we're going to do, looking closely at this, the area of a square is just the side length squared. So this is going to be, my area is side squared, and I'm going to subtract my area of a circle, which is pi times radius squared. And if we just do some quick math here, 25 squared is going to give me 625. 25 squared. And in order to get my radius, 25 is my diameter. So to cut that in half, I'm going to end up with half of 25, or 12.5 there. So I'm going to have 625 minus 12.5 squared times pi. Now, we can square 12.5, and you end up with 156.25, and we're going to multiply that by pi. So we end up with 625 minus 490.9. And at that point, you just do a little simple arithmetic. Do 625 minus your 490, and you end up with approximately 134.1. We're dealing with feet squared. So it's find the area of the outside and subtract the area of the inside. Okay, we'll take a look at 7 and 8, and then I'll allow you to do 9 on your own on another time. So when we're looking at number 7, my outside figure is going to be a rectangle, and my inside figure is going to be a triangle. So the area of my rectangle is going to be length times width, which is 25 times 14. And the area of my triangle is 1/2 base times height. And it appears that my base is going to be the 25 right here, and my height is the 11. So I'm going to do 1/2 times 25 times 11. And at that point, you just have to do a little bit of arithmetic. So 25 times 14 is going to give me 350. And 25 times 11 cut in half is going to give me 137.5. And when I subtract 350 from that 137.5, you end up with your area is 212.5 square centimeters, or centimeters squared. So the process is very similar to finding area. You're just doing it twice and then subtracting. Go ahead and try number 8, and when you come back in, we will have that answer there for you. I can tell you right now, you are going to have to do a little bit of work with finding your semicircle's radius. So go ahead and try that, and when you come back in, the answer will be there. Okay, welcome back in. So as you can see, my outer part was 1/2 of a circle. That tells me that this angle is going to be a 90-degree angle. So I had to use Pythagorean theorem to find the hypotenuse of that triangle, which happens to be the diameter. So when I did that, I found that my diameter was 23.4. To find the area of my circle, I had to cut that in half, and found 1/2 times pi times 11.7 squared. And then I found the area of my triangle on the inside and subtracted them. So the process is very simple. It's find the outside area, subtract the inside area. If there's multiple cutouts, you would subtract all of those multiple cutouts. You would just do subtraction after you found the area. If you have any questions, bring them into class, and I will see you then. Have a great day, guys. Bye-bye.